G'day everyone, welcome back. In this video we're going to have a look at how you can add a cheap LIDAR to your robotics project, and you'll get something like this. So in Foxglove you can see this is a top-down two-dimensional view of the LIDAR data. So we've got the robot over here in this corner, and then these three angled lines up here correspond to the monitors that you can see in the camera up here. So stick around and we'll get into it. Let's have a look at the LiDAR itself. So I bought the Slamtech RPLIDAR C1 model. This was about 150 Australian dollars on Amazon, but I actually just went on AliExpress, as I do with everything else, and got it for under $100, and it seems fine. You know, it wasn't a box full of rocks or, or whatever else you hear about. So the LiDAR itself, now this is all one unit, there's no moving parts. You might have noticed on some of the other LiDARs that they'll have a motor off to the side and then like a rubber band, and you can see it spinning, whereas this, it's all fixed, nothing moves, which is great when you've got little kids because they go and poke their fingers in things. Yeah, so on the top you've got an arrow down here, which would be the direction of travel for your robot, so you want to mount it that way rather than on the side. And then underneath you have some holes to fix it. Moving on, you have this board in the middle, and that's a bridge between the serial connections and USB-C. There is some holes in there, but it's shrink wrapped, so you'd have to drill through that if you want to fix it anyway. And then you've just got a USB-C to USB-A cable, and that's pretty much it. So just cable tie it neatly, find somewhere to fix that on the top of your robot. You want to put it on the top, you don't want to put it like down in the guts of your robot because then things are going to block it. So you want to put it somewhere up high where it's got a full 360 view. But yeah, that's pretty much it. So plug it in and let's get started. So I tried two different LiDAR packages. The first one I tried was RPLIDAR-ros, and chances are if you've been doing a bit of digging yourself, you may have come across the video from Josh from Articulated Robotics. If you haven't seen it, I do recommend you go and check out his channel. He's got some fantastic content on there. I've been learning heaps. And he did a video about 3 years ago on how to set up LiDAR, and he used one called RPLIDAR-ros. So I tried that one because it seemed convenient. It was in-apt. I can install it nice and easy. I've already got it on my machine, so it doesn't install anything. And then it gives you the ability to run this node. So ROS2 run, RPLIDAR-ros, RPLIDAR composition, and then you're passing it in some arguments for the USB port that the LiDAR is on, the frame ID, and then some other arguments here. Now, when I ran that, nothing seems to happen. It just gives me an error. I did some more digging online. I went for a bunch of different forum posts, and people suggested changing this to be false, changing that to a different type of scan mode, and even changing the baud rate. And I tried various combinations of those things, and every time it would just give me this error, which is kind of annoying. So I went over to the documentation for this, and I checked here, and my model is apparently listed, the C1. So I had a look at the code, and I noticed that it hasn't changed in 7 years. And also the documentation mentioned using a ROS2 branch, but there isn't a ROS2 branch or a tag, so I kind of figured that maybe that one's a little bit broken, and I didn't want to invest any more time in that without checking out some alternatives. The second package that I found is called sllidar ROS2 from Slamtech, and after a bit more digging I found out that the RPLIDAR package was built for ROS1, and then they added in a branch for ROS2, but that seems like it's not on GitHub anymore, whereas this package here was built specifically for ROS2, so I figured my chances might be better here. It does list my C1 as well as a supported model. So this one was a little bit more tricky to install because it doesn't have a package in apt, so you have to clone the repository and then build it from source yourself. But honestly, it wasn't too hard. So if I jump over to VS Code, so I'm in my home directory right now, and if I show you what I have in my home, so robotics is my workspace, and that's tied to my GitHub repository. So I didn't want to clone out the sllidar into that directory because it's already managed under Git. So what I did was I cloned it alongside here. And then if we go into that sllidar, so the first thing you have to do is you need to source the ROS Jazzy setup file itself. So if you do that, and then the next thing you need to do is a colcon build. All of this is in the GitHub repo anyway. I'm just trying to show you how easy it is to get going. So you run that build, and then you can run one of the samples that they provide you. So they give you some launchers for your different models. So if I run that one, you won't be able to hear on the mic here, but I can hear the motor in the LIDAR spinning up behind me now after running that. It does give me an error about RViz, and I'm not running RViz, so I don't really care about that. But I can hear the LIDAR spinning, so I know it's working. And we can confirm that if we go over to a second window and do ROS2 topic list. So it'll put it out to the scan topic by default, and then we can do a ROS2 topic echo what's on that scan. So yeah, these are all the data points that it's getting as it's spinning around, taking laser readings. So I was pretty confident that that library would be a goer. So the next step was to figure out how to integrate that into my robot. Okay, great. So it looks like sllidar is going to work for me. Now, how do I get that into my robotics project? That's where I came across something called vendor overlays, and that gives you the ability to have layers in your workspaces so that you can check out different projects from source, build them, and then they become available to your workspace. So what I did was in my home directory, I created a new vendor workspace directory, and then I checked out the sllidar project again into that directory. Now earlier in the video I did show you in my home directory I've got the robotics workspace, and then I did check out sllidar there. That was just to test it. I have also checked it out under this vendor workspace. And the reason I do that is because in the future, if I need to check out another package and build it from source, I can put that all into the same vendor directory, just so I don't have things scattered across my file system. So what you need to do next is go into that workspace. You need to source ROS Jazzy. Then you need to do a ROSDEP install just to make sure all the dependencies for the vendor workspace are available. And then you can just build the whole thing. And that would mean that the sllidar package will be available to you. You do have to do one extra thing to get it into your workspace, and you have to source the setup.bash from the vendor workspace. So I've got a make file, and I do that because it's just much easier to remember, isn't it, really, rather than having to type out this whole line every time you want to do something. Instead, I can just do make launch or make build or make clean, you know, any of those things. I'll put a link to this. It's all in my repository anyway, so you can go and take whatever you need from there. But yeah, so whenever you want to run, you have to source your own setup.bash from your own workspace, and then you also have to source the setup.bash from the vendor workspace. And then you've got both of those layers to play with. So having a look at my node, so I've got a package called sensors, and that just covers the camera, the microphone, the speaker, the LLM, you know, basically like human sensors, really. And I added in another node from the sllidar package, sllidar node, and then these are the parameters. They're pretty much the same as the RPLIDAR parameters, I believe. So yeah, frame ID, scan mode, and so on. And then when I launch the sensors, it will launch this node and everything works. And the good thing about doing this is if I look at my main launch all file, I've also got the Foxglove bridge in there. So that's how I can get the data from the scan topic out into Foxglove. So what I'll do now is I'll get rid of this out of the way. So if we go into the robotics workspace, and like I say, I can do a make build. I work with so many different technologies and frameworks. It's so hard to remember all the command arguments. You know, I'm doing this, and then I'm working with Amazon, and then I'm doing AI stuff, and I just get lost in it all, which is why I prefer Makefiles. So I did a make build, then I can do a make launch. So this is just starting up everything. There will be an error there. That's around GPIO. I've broken something else around GPIO, but I don't need that for this. That's fine. But it started everything up. I can hear the LIDAR spinning. So if we swap screens into Foxglove, so this is the visualization panel. It's a 3D panel, but it's actually operating in 2D mode. So this is like a top-down view of the LIDAR. So the robot is over here. That's behind me. And there's a monitor beside the robot. This set of 3 lines up here, that's actually my monitors that I'm looking at. So I've got the laptop in the middle and then a monitor either side. And then this little curly line would be my back. And that's pretty much it. You can see it's got the part of the bookcases and that down here. And then if I move, you can see me moving. So it's quite responsive. You know, there's no delay in it as I'm moving closer to the robot. Yeah, so that's pretty much it. So there we go. That's how you can add a LIDAR to your project in about half an hour. I thought that was going to be a lot harder than that, but it turned out to be not too bad. So I'm going to do some more of these SLAM videos coming up over the next few months. I have actually been out in the shed today, which is why I've got my high-vis stuff on. I've been trying to build like a fake house inside my shed, using lots of cardboard boxes and bits of wood that I've been saving forever. And the idea is that I've got this sort of scale model of a house, and then I've sectioned it off into different rooms, and I can get the robot to sort of navigate around. It's going to take me a little while to figure that all out, but eventually I'd like to add in some agentic AI as well, so I can say, hey robot, navigate to the dining room, and it knows where that is, and it will take itself off and do that. But obviously I've got quite a lot to learn, but it's always good to have goals, isn't it? I probably should check out Gazebo, but nah, we'll just go and do it in the physical world, make it a bit harder. So yeah, anyway, until next time, stay curious and keep learning. And don't forget to thumbs up down below too. Thanks all.